Today we're going to be figuring out how to modify the TikTok iOS app so that it only shows cat videos. Doing this for two reasons. One is to show kind of an end-to-end example of how you as an iOS developer might go about reverse engineering a third-party app, especially one like TikTok that has a bunch of security measures baked in. And the other reason is just because I think this will be an improved app. I don't think that requires much justification. So at a high level, what we need to do here is reverse engineer the app, specifically the parts that control what posts are going to be shown. And that's a big nebulous task, but we'll figure out how to dive into it in a second. Once we've done that, we're going to take the original TikTok app, we're going to create a framework whose job is to modify some part of the execution of that original app, and then we are going to bundle them together to create a new app. Cat talk. Hi Beans, we're making an app for you. She doesn't care. So again, the first step of that process is reverse engineering to figure out what part of the original app we need to modify. My expectation is that somewhere there's a data structure that holds all the videos that can be shown on the main feed. We want to find where that data structure lives and figure out how to modify it. And there's a bunch of ways we can approach something like this, where we have a clear goal that involves changing the logic somewhere in the middle of the app. What I find easiest is to focus on places where the app interfaces with another system and then to work backwards from there. Like we can hook into the place where the app makes actual API calls and modify the response. That way we don't have to know much about TikTok's internals, we just need to know how to parse and modify JSON. And on the other end of that pipeline, we can look at where the app talks to UIKit. Like if this main feed screen is implemented using a collection view, then at some point there's probably a collection view data source that is determining what items to show. Maybe we can hook in and do some filtering there. Our goal is to figure out what high-level options we have and which one is going to be easiest. I want to start by looking at the networking side. For a lot of apps, this is the easy option, and it's very quick to find out if you're looking at one of the apps where it is not the easy option. So it's a good starting place. So here's what we're going to do. We're going to run this phone through an HTTP proxy. You might already use these during normal app development. It's basically an app that'll let you see most network traffic to and from your phone. So I'm using an app called Charles. You can see it right up here. We'll skip most of the setup, but the way this generally works is that there's some option in the tool to install a certificate on your physical device, and then you update the networking settings of that device to route through your computer. Now, if we've set up everything correctly, we should be able to open an app like IMDb and see all of its traffic coming in. And if we go and search for something like hat, somewhere in this list of requests, we should have a request corresponding to that search. And we can click in here and see exactly what the search responded with. Like the first result was for the cat in the hat. The next one was for Anne Hathaway. So if we were making this mod for IMDb, we might look in the app to see where this request is made. And then we'd look for this JSON response filtered to just items mentioning cats, and then forward that response along to the app's normal handling, and it will just show us cat results. Now I mentioned this is only sometimes the easy option, and that's because there are a few things that an app might do to make this plan of attack harder, especially as it grows or has more aggressive performance needs. Some of the biggest ones are like certificate pinning, or using a binary encoding format instead of JSON, or using a more complex protocol like WebSockets, stuff like that. You can totally work around each and every one of these, but it'll require more work, and it might be a good sign that you should look for somewhere else to hook in, like in our case, the V layer. Anyway, all that is to say that TikTok is a large enough app with significant enough security concerns that I'm betting we're going to run into at least one or two of these, which is why we've started with IMDb instead of TikTok. But let's open it and see what happens. I'm going to clear Charles so that we can just see TikTok requests, and I'm going to tap to open, and nothing. Okay, so immediately we see an issue. As we expected, we have a couple small things from like tracking SDKs here, but overall the app just fails to launch. This looks like a case of certificate pinning or some other sort of certificate validation. A super simplified version of how certificate pinning works is that when the app goes to make a request to its API, the networking library it's using will have a callback that's like, hey, is this the certificate for the server you expect? And the app can have logic in there to say, yes, that's the certificate I expect. Or in our case, no, it looks like I'm not talking directly to TikTok servers, and therefore I'm going to shut things down. But we do have one more quick thing you can try if you have access to a jailbroken device, which this is. And that's a tool called SSL kill switch, which basically looks for those callback functions in a bunch of known networking libraries. And if it sees one, just hooks into that implementation to say, yes, that certificate looks good. There's more complexity there, of course, but that's the root idea. It doesn't work in every app, especially apps that may have invested in preventing this specific type of reverse engineering work, but it's also super quick to try. So I'm going to go into settings. I already have SSL kill switch 3 installed, and I'm just going to toggle the switch so that we're skipping certificate validation where we can. And I'm going to close out of settings in TikTok, reset Charles here, and then let's go ahead and reopen. Again, I'm not overly optimistic. Yeah, okay. So again, this is kind of the outcome we were expecting. For an app like TikTok, poking around in the networking side might end up being harder than it's worth. But again, sometimes it is the fastest option. It's super quick to check, so I'm glad we did. And again, we could totally work around this with enough effort. There's still code somewhere in this app that's responsible for checking if the certificate is valid, and we could find it and disable it. But we're at the point where switching to a different area of the app will probably give us easier results. So let's do that. Let's look at the UI side instead. So I'm going to start by closing out of Charles and setting my device back to normal network settings. Now I'm going to launch TikTok again on my jailbroken device, but this time we're going to attach attach a debugger to it and poke around and see what we can find. Okay, so let's go ahead and put a terminal window right here. And what I'm going to do now is just SSH into this phone. And now I'm going to launch debug server and point it at TikTok. We can see that the TikTok app froze. Now I'm going to start LLDB on my Mac. And the first thing we're going to do is say that we are connecting to a remote iOS device. And now we'll tell LLDB to actually connect to that device. This is going to take a second. Cool, so now we're stopped in the TikTok app. We want to look at the view layer size. So just to get an initial feel for what's going on, let's look at what the view hierarchy looks like. There's this neat private method on UI window and UI view called recursive description. So let's call that on our key window. What we should get is an output of basically everything on the screen. And what we can do from there is, here we go. It's a bit of a mess. Okay, now I'm going to go ahead and copy this over to a different editor so that we can see it more easily. Here's our view hierarchy, and we can see we're starting with this window up here, and then we've got all sorts of navigation and general view controller stuff. Over here we have a table view. That's probably the main table view for the feed. We can see that its size basically takes up the whole screen, so that makes sense. I will say if you're doing this more, there's more useful tools you can use like Flex to get a quicker view of the hierarchy, but this will work for us. So it looks like every feed post is probably a table view cell within this table view. So what I'm expecting is that somewhere there's some data source that's looking at what posts we have available to tell the table view what to actually display. Like we can imagine a super simplified version of this where the table view's data source implements number of rows in section, as you have to for every table view, and that just looks at some property that is an array of posts and returns its count, right? Like this is what we're trying to find, where those posts live. So there's a couple ways we could figure out where this data might live. One or two quick things to help with that. I'm going to go back to LLDB, and I want two pieces of information. I want the name of the class that is the data source for this table view, and I want the name of the view controller that owns this table view. Both of those seem like they could have useful information on them. So what I'm going to do in our view hierarchy printout over here, we have the address of all these views on screen. And over here in LLDB, I'm just going to treat that address as if it's an object, and I'm going to ask it for its data source. And there we go. So now we know a TTK feed table view service acts as the data source for this table view. So we can do a similar thing for the view controller. UI view doesn't have a method on it that gives you the view controller directly, but you can call next responder. If your view belongs to a view controller, that'll give you the view controller. Otherwise, it'll give you your super view. So what we can do is just basically keep calling that over and over again. LLDB is able to figure out that I'm missing the square brackets at the beginning and fixes it for me. We'll call that until we get a view controller. There it is. So it looks like this table view belongs to a AWE new feed table view controller. That feels like plenty of good insights for now. So let's switch it up a bit. So now we're going to open TikTok in a disassembler, which will let us look at what methods exist in the app, what they do, how they call each other. Between a debugger and a disassembler, we should be able to figure out basically anything about how an app works, given enough effort. So first step is that we need a copy of TikTok on the computer. And specifically, we need a decrypted copy versus one straight from the App Store, which will be encrypted with Apple's Fairplay DRM and not going to be useful for analysis accordingly. If you have a jailbroken phone, you can use a tool like Clutch to dump a decrypted copy of the app straight from your device. Otherwise, I'd recommend using a site like this decrypted iOS app store. So either way, we have a copy of TikTok here. We need to be able to look inside it. So the first thing I'm going to do is rename this .ipa file to .zip. All IPA files are really just zip files in disguise. So now with this rename, we can just double click to unzip it. And now we can click into this payload folder. We need to do show package contents on this app file. And now here's all the actual contents of the TikTok app. We're going to want to open an executable file in our disassembler, but there might be multiple in here. Like there's going to be this main TikTok binary here, but we probably also have a frameworks directory that's full of all sorts of other ones. So what I'm going to do is a dead simple check to figure out where this table view logic might live. And that's back here in terminal. I'm literally just going to grep for one of the file names we were interested in. I'm going to use ripgrep for speed, binary to say search in binary files, and then let's search for this class. There we go. So it looks like this class is implemented in Musical.ly core. This isn't always a perfect method, especially if the class is referenced from multiple frameworks, but it is fast, and if only one comes up, that's probably what we need. So coming back over here to Finder, I'm going to go and find that framework, Musical.ly core. So what I'm going to do is open Hopper, which is a disassembler that I found works pretty well for iOS projects, and I'm going to go ahead and drag Musical.ly core in. All these defaults should work fine for us. And it's going to take Hopper a while to do its thing, especially given this is a pretty large binary. So let's check back in a bit. Okay, I am back with breakfast. How's everything going over here? So things so far look different than what we'd normally expect with the disassembler. For one, Hopper says it's still working, though I'm not sure what on. But for two, it's able to see all these classes, but it is not able to find most of the methods on them. Instead, we see all these super short subroutines that are just a couple instructions long. And if we look at what Objective-C methods Hopper does recognize, they might be an instruction or two, and then all of this binary data that it's not able to parse. So this makes me think that TikTok is applying some obfuscation to the binary itself. It's not super common for iOS apps, but it's also not unheard of. That means that this assembler probably won't be helpful to us, but also that's fine. Being able to combine static and dynamic analysis, like with a disassembler and a debugger, is super helpful, but if we just have to make do with one, we can. So let's hop back to our debugger. Even if we're not able to get a list of methods in the app using a disassembler, that list of methods still needs to exist, and the Objective-C runtime still needs to know about it, which means we should be able to ask the runtime for those methods. There's a super convenient private method on NSObject that prints out the list of methods in a class, so I'm going to use that to print out all the methods on TTK feed table view service. That was the class that was acting as our table views data source. And this is a funny method in that it's an instance method on an NSObject, so you can just pass whatever NSObject to use as the receiver. And here we go. So here are all the methods implemented by that class. And if we scroll up a little bit, we can see the normal table view ones we'd expect, because this is a table view data source. Like here's table view will display cell, table view number of rows in section. So there's a bunch of different ways we can go with this, but one method I'm super interested in is number of rows in section. And again, that's because the naive implementation that might look like turning around and asking some array of posts what it's counted so that we know how many rows to show. So let's go back to LLDB, and what I'm going to do is I'm going to grab this address that's printed out after that method. This is where the implementation of that method actually lies, and I'm going to create a new breakpoint using B, which is short for breakpoint set, -A for address, and pass in that address. Now our breakpoint is set. Now I'm going to continue execution, and then I'm going to pull the refresh in TikTok, and here we go, our breakpoint is triggered. There's a bunch of ways we can go from here to try to orient ourselves. What I'm going to do is I'm going to do DI for disassemble, and let me actually expand this now so we can see a bit better. So now this is a disassembly of the method we're in, and I think TikTok's binary obfuscation is messing with us here too. Like I would expect the LLDB to recognize some of these symbols here, like calls out to Objective-C message send, but it's not recognizing any of them. And this many branch with links in a row seems super suspicious to me. Like if we copy the address of one of these, and then we do DI again for disassemble and pass that address, and we can see that's mostly a nonsensical method, like it's just running 2 instructions and running back to where we were. So all this is a bit weird. It's definitely designed to make the control flow harder to analyze. That being said, we can still piece things together with enough effort. Like this one to me looks like a real method call, and the reason for that is this combination of instructions up here. Every Objective-C method implicitly starts with the same first 2 parameters. That's self, which is the instance that we're calling a method on, and CMD, short for command, which is the selector that we're calling. We can see this from where we're stopped right now. Remember, we're stopped at the beginning of TTK table view service, table view number of rows in section. That's where we set our breakpoint. On ARM devices, the first argument to a method will be passed in register x0. Mostly, the next one will be an x1. So if we ask LLDB to print out the value of x0, we get self. That's an instance of TTK feed table view service. If we ask it to print out x1, we'll get mostly gibberish, since this is just the address of our selector in memory. But what we can do instead is wrap that in a call to NSString from selector, and then we'll pass in $x1 right here. And now we get an actual selector name back, table view number of rows in section, like we expected. Point being, this combination of instructions up here is loading some constant value from a fixed address into register x1. That constant value could be anything, but this is a common setup for loading an Objective-C selector into x1 before calling an Objective-C method. And if that's the case, then right afterwards, we would expect a branch instruction to actually invoke that method. So this could well be an Objective-C method call. So what I'm going to do is I'm going to set a breakpoint on this address right after we've set up register x1. And again, I'm going to do that with just B-A and then that address. And I'm going to continue execution until we've hit that breakpoint, which we just did. Now, if this does correspond to an Objective-C method call, at this point, right before invoking the method, we'd expect x0 to contain the instance we're invoking the method on, and we expect x1 to be the selector of the method we're calling. So let's check. I'll print out x0. We have an Objective-C instance here. It's the same instance we saw before, so this could be from this method invoking a method on self. And now let's ask x1 what selector it corresponds to, and it's number of rows in section. Critically, that's different, even if it sounds similar. So what we can gather from this is that in this implementation of table view number of rows in section, we actually just call out to a helper function called number of rows in section that doesn't take that table view parameter. This method might be as simple as just returning this value. It might take this and just store it in some intermediate result. Point being, we can gather insights about how the app works by kind of going through the disassembly like this. And we could do this very methodically on repeat until we have a good understanding of what the overall structure of this method looks like and like what other methods it's calling out to. But that will take a while, and it'll be slowed down by TikTok's obfuscation here. That's our fallback if we need it, but we might be able to find some shortcuts here. So I'm going to go back to looking at the method list for this table view data source. My expectation again is that at some point this method or the helper method that now we know it's calling out to is looking at some property that this class owns to figure out how many posts it has. So I'm curious if any of the property names here jump out. We can scroll up past all these methods and we should actually be able to see a list of properties. So here at the top, we can go through the properties one by one. The first one is a reference to the table view corresponding to this data source, which makes sense. We have a couple ones related to delegates and dispatching. We have one here called data service, which sounds pretty freaking interesting. Could also be unrelated though. So the first thing I want to do is check if this data service property is accessed within our number of rows in section method. And the way I'm going to do that is scrolling back under the properties down to the methods, and there should be a getter method for this data service. Here it is. And I'm going to grab this address and then again set a breakpoint on it. Now what I also want to do is look at a disassembly of our table view number of rows in section method again. So I'm going to go ahead and do di and give the address we saw earlier for that. Now what I'm going to do here is set a breakpoint on this last instruction in this method, and I'll do that with b-a with that address, because from a quick glance, all code paths should go through this last instruction, which means when this new breakpoint is hit, breakpoint 4, it means we've reached the end of our number of rows in section implementation. Now I'm going to hit continue, and we hit breakpoint 3. This is the breakpoint for that data service getter, which means we access that data service property within the number of rows in section implementation, because we hit this before we hit the breakpoint at the end of that method. So this is great news. Now we know the structure looks something closer to this, where we have our table view data source method that calls out to some helper method, and within that helper method, we access a property called data service. So let's continue down the line here. We're paused right at this called the self data service. So if we print out x0, which should correspond to whatever self is, that should still be our overall table views data source, which means we can now turn around and ask x0 for this data service property we just learned about, and we get an object back. Now let's do a similar thing as before. I'm going to ask this new class, ttk feed data service, what its methods are. And if we look through its properties, we can see, again, some generic NS object ones. We have one called table view service, which seems super interesting. Okay, we also have this one here called data controller. Both of those seem like they could be candidates for where the actual data for this lies. So what I'm going to do is just set a breakpoint on each. We have the getter for table view service here. I'll set a breakpoint on it. And we have the getter for data controller right here. We'll set a breakpoint here as well. So we've got 5 for the table view service, 6 for the data controller. And I'm going to just continue execution, and we hit breakpoint 6. And critically, we still haven't hit that breakpoint at the end of this number of rows in section implementation, which means we now know that this implementation looks something closer to this. We access the data service property, and then on that data service, we ask it for its data controller. So let's see what that data controller looks like. We're stopped right at the start of this method right now. So if we PO x0, we should still have our data service object here. So I'm going to then ask that data service object for its data controller, and we have an AWE hot list data controller. And you know the deal, I'm going to ask that class for its methods, and just scanning through now, none of these immediately seem super interesting to me. For what it's worth, I'm reading these much slower without the editing, do not worry. But none of them seem super interesting. One more thing that we can check is that this call that we've been using to get a list of methods on a class only works for the class's direct methods, not any of its superclasses methods. So if I ask this class if it has a superclass, it does. Let's do the same thing with this superclass. And if we go up, we have a mutable array called data source. That sounds super helpful. Let's check what that looks like. So again, x0 right now is still our feed table view service. So I'm going to ask x0 for its data controller, and I'm going to ask that data controller for its data source. That was that array we were just looking at. And this might be where our data actually lives. This is a lot of properties, Jesus. Here we go. I think these really are our feed posts. Like we have this description string property that includes basically what this caption looks like, although I think it's for a different video. That's then perfect too, because we can look at this description and see if it contains the word cat to make at least a rough guess on if we're looking at a cat video or not. So we're pretty deep in the woods here, but just to back up for a second, I'm going to go ahead and disable all breakpoints except for our first one, that one on table view number of rows in section. And I'm going to go ahead and continue execution in the app, and I'm going to refresh, and now we're stopped back at the start of that method again. So from here, let's make sure we're able to access that data property. So it should be x0 data service. This is our table view data sources, data services, data controllers, data source, which is just incredible. Perfect, okay. So we can access this array of posts from our table view data source methods, and they look like they really do contain all the information about the videos. Like it looks like this probably is the real data source, but we don't know that for sure. It seems pretty likely, but this could also be a copy of the post we received without actually being the source of truth for the table view. It's worth confirming before we go any further. So easiest way I can think of to do that is we're gonna go back up, get the address for the getter for this array we're looking at. So here's the property. There's also filter data source here, but I'm not worried about it for now. I'm assuming that's derived from data source. If this doesn't work, maybe we should look at filter data source more. But we're going to go down and we're going to find the getter for data source. Here we go. And I'm going to set a breakpoint on it. Now I'm going to use breakpoint command add, which we can write in short form as brcom add. And this is going to let us run arbitrary debugger commands whenever this breakpoint is hit. And I'm going to add 2 of them. I'm going to add thread return with an empty array. So this makes it so that whenever the getter for this array is called, we skip the actual implementation and we just return an empty array. And then I'm going to use con to automatically continue execution whenever this breakpoint is hit, and then done to mark the end of our commands list. And the end result is that we've effectively stubbed out this method to always just return an empty array. If this array really is the true underlying source for this table view, then when we continue execution and the app sees an empty array here, I'm expecting us to see an empty table view too. So I'm going to disable all breakpoints again and then re-enable just that last one, so it's just this stub that's happening, and then we'll continue execution. You can see the breakpoint getting hit over and over again as LLDB processes what's happening, returns our array. Oh my gosh, there we go. We have just a completely empty table view back. The app should be running right now, so like we can pull a refresh. It will go through the same motions again. Every time we're asking that property for data, it's returning an empty array. You can see the app kind of pausing and resuming. And yeah, perfect, empty table view screen. So it looks like this really is the data source that the table view is using. So now we finally have a concrete plan for our modification. We can hook into this getter method, and then anytime anybody asks for this data, we look at it first, we filter down this array to just posts with descriptions about cats, and then we pass that filtered array along to the app's normal execution flow. We've talked a lot about hooking into different kinds of methods, but we haven't actually seen what that looks like yet. So let's get that process started. So let's open Xcode, and we're going to create a new iOS framework. So I'm going to name this project Cat Talk, and I'm going to change the language to Objective-C because the less strict typing usually makes fun stuff like this easier. And it gives us a header file to start with. I'm going to go ahead and add an implementation file to match that. So our end goal is to make this class responsible for hooking into that data source method we saw. But to start with, I'm going to make things a lot simpler, and we're going to add a load class function. This is going to be called whenever this class is loaded, which in our case is going to be at app startup. And I'm just going to add a basic log statement here. And so what we end up with is a framework that when loaded should just print out a log. So I'm going to go ahead and build this framework, which is completed already. And I'm going to go and open that framework in Finder. It should be under products, cattalk.framework. Perfect. Now there are a couple ways to actually get this on our phone. I'm going to use an app called Sideloadly that should make most of it pretty easy. So back over here in Finder, I'm going to take the IPA that we downloaded and we'll fix the extension because we changed it temporarily. And I'm going to drag this over here to the IPA field in Sideloadly. I'm also going to click this button here for advanced options. And we can see down here, there's the option to inject a dynamic library or a framework. So I'm going to check that. We'll ask for a framework. And then I'm just going to go take the framework we built and we'll say inject that. That should be all we need. I'm going to hit start and it's going to start doing its thing. So this is doing a couple things for us. It's setting up the app to load that framework and then it's bundling everything together and re-signing it. You can also handle all this yourself. You can use something like optool to actually inject a dynamic library into the app. You can package and sign the app yourself from the command line. You definitely have options, but this is a pretty quick and easy one. So now we can see at the bottom here, just mark the installation is done. If we bring up our phone screen, we can see TikTok has that blue new app bubble near it. So now the only thing we need to do before actually launching the app is have a console window open so that we can look for logs. So I'm going to select my phone in the sidebar here. I'm going to hit start streaming, and then we're going to say filter to just logs from the process named TikTok. There aren't any right now because TikTok isn't running, but as soon as we tap on this, we'll hopefully get some. And here we go. We've got a bunch, including this Cat Talk loaded one. So we can tell that our tweak is actually working. Perfect. I'm going to go back to Xcode, and now we can actually start building this thing out. This is an Objective-C method, which means we can just swizzle it. We define our new method implementation, we find the existing method implementation, and then we can ask the runtime to just swap them. If you're hooking into a pure Swift function or like a C function, you might have to do something more interesting, but swizzling works for us. So let's start by defining our own method implementation. I'm going to create a new instance method that's going to return an NS array, and we're going to call it swizzle data source. Now, the first thing we're going to do in this method is get a reference to the original array that would have been returned. And we can do that by calling self-swizzle data source. This looks perfectly normal if you're familiar with swizzling already, but if you're not, this can look super weird. Calling this method in this context will actually invoke the original implementation. We'll see why in a sec. Now we're going to go ahead and create a filtered version of this data, and we can do that by calling original data filtered array using predicate. We're really pushing up against the bounds of this font size here, but we have a predicate that we're going to use to filter down this array. And we saw before that each post had a property called description string, and we can use that to check if it contains the substring cat. Xcode's going to complain that it has no idea what this description string is. We could define our own types here and make sure that we're casting everything to the correct thing, but instead I'm just going to say that any NS object might contain something called description string. Now we should just be able to return our filtered data here, and that should be enough for that actual implementation. I am going to add one log statement here to print out how much data we started with and how much we filtered down to, just so we can kind of see what's happening in the logs, but that should be good for this implementation. Now what we have to do is set up the actual swizzling. So I'm going to come up here to our load method, and we're going to add a new dispatch once block, and we're going to do a mostly normal swizzling setup, but let's walk all the way through it. I'm going to define what class we want to swizzle things on, and that's going to be AWE list data controller. Xcode knows nothing about that class right now, so to keep things easy, we're defining it as a string and then using NS class from string to create a class from that. Now I'm going to define two selectors, the first of which is the original method name, so that's just data source. Xcode doesn't know anything about that method either, so I'm going to go ahead and add it up here just like we did for description string. And then our second selector is the name of our replacement method, so in that case that's swizzle data source. Now this is the one part where things are going to differ slightly from the most common swizzling setup. Normally you would implement this on a category for whatever class you want it to swizzle, but that's difficult for us because again, Xcode doesn't know anything about this class, so we can't easily define a category on it. What I'm going to do instead is use this selector to get a reference to our swizzled method, that is this one down here. Now I'm going to use class add method to add this method, this new data source implementation that we made, to our target class, which is again AWE list data controller. So after this call, from the runtime's perspective, it's almost like the original TikTok authors wrote this function called swizzle data source that had this exact implementation as part of their original class. this. Now I'm going to get a reference to the method we want to replace. That's the one called data source on our original class. And I'm going to get a reference to the new method we just added. That's the one called swizzle data source on our original class, which again, we just added right up here. And then the classic swizzling setup, I'm going to call method exchange implementations to swap the implementations of those two methods around. So if somebody calls the data source method on that original class, they get this new implementation instead. And critically, if you call swizzle data source, you get the old implementation. So if you hadn't seen it before, that's why we have this funky recursive looking call to get our original array, because this will now end up calling our original implementation. So that should actually be everything we need from the Xcode side. I'm going to go ahead and build it again. One last thing before we actually install this, you might have noticed that this is only going to work if the API is actually sending us some cat videos to begin with. Otherwise, we're filtering out everything here and we're just going to get an empty screen. I'm not worried about this long term because TikTok is very good at figuring out what you like to watch. So if we're seeing only cat videos, that means we're only watching cat videos and the algorithm will keep sending us more and more cat videos. It's a wonderful self-fulfilling loop, but it means we need to have at least some cat videos first, which means that for science, I need to sit here and watch cat videos on TikTok until we can be confident that the algorithm will send me at least some. So I'll check back in a bit. Okay, that was, I don't know how much time that was, but that felt like it should be enough. So let's try it. I'm going to open sideloadly again. We still have all our same settings from before. Let's go ahead and install this again. This should still be pointing to the right framework, just the updated one. And I'm going to come over to our console and we're still going to filter just to TikTok messages, but now just ones that contain the string cat talk as well. And we'll clear that out so we're ready for next launch. Okay, so installation just finished. Let's switch back to looking at the phone screen. We're going to launch TikTok. We're praying for some cat videos and only cat videos. Okay, so we received 8 videos from the API, but based on this console message, we filtered just down to this one cat one. I'm not able to scroll to load more currently, but I think it might just be because we only have one object in the table view. Let's see, we're hoping for at least a couple cat videos from the API here. So we're starting with an empty page, which makes sense. Okay, I read this as we were sent 8 videos from the API, but we got 2 back after the filtering. Does pagination work? Like we only received those 2. Pagination doesn't seem to work so far. And now we're just out of post entirely. I have a suspicion of what might be happening here. Okay, so we saw the app was behaving a bit erratically with this change. So let's try to make some guesses at where that's from. One thing that jumps out to me, we're looking just at this one data source property, but in LLDB, we saw that there was a sibling property called filtered data source. I was assuming filtered data source was derived from data source, but they might have a different relationship than that. And maybe we should filter both because maybe data source impacts what we display, but filtered data source is what matters for being able to page, something like that. We're also only modifying the getter for this array, not the underlying array itself. We saw this was an NS mutable array instance, which means we could just modify its contents directly. That'd be helpful if there's any methods looking directly at that IVAR instead of going through the getter. So let's do a few things here. Instead of swizzling this getter, let's swizzle one of the table view data source methods. That'll give us a central place from which we can modify both these arrays. So I've changed this setup to swizzle table view number of rows in section. Now we have to update this implementation. We already saw in our debugger how to get this data array from our table view's data source. First, we access our data service property, and then we access the data controller property off of that data service. Xcode again doesn't know about either of these methods, so I'm gonna add them up here. Now we can ask that data controller for its data source, which was the array whose getter we were swizzling earlier, and we can do the same for the filtered data source array, which we haven't looked at yet. Now I'm gonna copy this existing NS predicate that we created, and I'm just gonna put it into its own variable. And now we can tell both of our data sources to filter themselves using that predicate. So now anytime table view number of rows in section is called, we're gonna look at both of these data source mutable arrays, and we're gonna filter them down to just the cat parts. There's one thing missing here, which is that we're supposed to return the number of rows in this section. So I'm just going to fall back to our original implementation for that. And now we should be golden. So let's try building this. And now we're going to install it again through sideloadly. And looks like it finished. So let's bring up our phone view again and we'll launch TikTok. And we're hoping we get some cat responses from the API. Hopefully a couple. Let's see. Okay, we have a cat. Let's see. Let's keep scrolling. Okay. We have a second cat. That's good news so far. So we were running into issues before where we couldn't keep scrolling. So far, it seems we might have just cats. I think we've done it. I think we've successfully invented cat talk. Oh, and this is so much better. Like, it is such an improvement. Okay, I'm going to close TikTok for now. We've got one more thing left to do, which is to make a more appropriate icon for this app. So let's see, I'm going to open our IPA in Finder again. We'll go into this payload folder and we're looking for one of the app icons. We should have a couple. So I'll take this non-iPad one and let's just throw it into Photoshop real quick. Bam, bam, bam. Let's go ahead and save this. Back over here, I'm going to use a tool called IPA Edit. We're going to pick our original IPA. It's going to process it for a second. And now we can change the name to Cat Talk and change the icon to our cat icon. And let's export the IPA. Perfect. You can also make the same changes yourself by modifying things in this payload directory and then repackaging the IPA. But just like with sideloadly, This makes life easier. So I'm gonna go ahead and drag our Cat Talk IPA onto here. I'm gonna hit start, and I'm hoping at some point we're gonna be able to see the TikTok icon actually switch over. There we go. And with that, finally, we have a working Cat Talk. We finished. We have successfully modified TikTok despite all the protections it had in place, including some fun ones. There was more assembly in this video than I expected. But I hope this is a good example of both some of the individual techniques you might use when reverse engineering a lockdown app like this, and also the fact that this is just a weird process. And that's great. That's where half the fun comes from. And that's okay if it takes a bit for you to get things working. But anyways, I'm gonna go watch some cat videos. Thanks for watching.